Welcome to unit testing with the JavaScript API. I'm Randy Jones. Presenting with me is George Bohenik. We are in Esri Professional Services, if you haven't been to one of our talks before. So we work with clients sort of at any stage of their enterprise or architecture or app development cycles. So sometimes we just come in and advise customers on how best to build their apps, design their architecture, and sometimes we take those things all the way into production for them. Oftentimes we will then hand the keys back over to the customer, so to speak, let them continue to maintain and their system or their applications. So we're based out of the DC regional office, and so we end up with a number of unique challenges working in that area of the country. So, is that gonna work? No, okay. So last year, we really love the feedback that we get from everybody. We gave a similar talk last year. And last year we talked a lot about the vocabulary of unit testing, and we'll have to hit that a little bit this year too. And we talked a lot more of tools and things like that. And maybe not as much sort of demo live focused on how to integrate those specific tests into your code or modify your code to meet those tests. So what are we changing this year? So this year what we're going to do is we're going to go demo heavy. We are going to start with some ground rules here, and then demo. So we'll talk about new applications, what our suggestions are. We'll talk about an existing application, how to bring that in. George and I have this wonderful application that was perfect, best practices and everything. And that was like 3 years ago, so now it's old and legacy and our great demo application for that. And then we will talk about some fanciness with React, and then we'll go into Web App Builder as well, and talking about those things. So how do we test our code? Most of the time, this is the cycle that we find the developers end up in. They write code, they test their code, they write some more code, and they break their test. So they rewrite their test. And that's not necessarily solving the problem that we're trying to test for. So we don't want to follow this methodology if we can help it. That's not to say that we never have to refactor our tests or go back and rewrite anything. But as a general practice, we want to keep in mind we want to be writing our tests to test for the things and not writing our test for how our code is written. So if we sort of flip this around and start thinking from the testing perspective, we get this concept that is you may have heard of already before, test-driven development. So we're starting with the test in mind first, writing that, and then centering our code to meet the requirements that we've spelled out in our test. Now sure, this takes a certain amount of understanding of the framework you're using, what you're trying to implement. So we're not saying day one, the very first thing you do when you start a new application is you write your first test. Right? That's unreasonable. None of us are going to test. Well, we probably all don't test already, right? How many people are writing unit tests right now? Wow, good. That's probably the most hands we've ever seen at one of these, so that's encouraging. And all the rest of you are really excited to tomorrow go implement this in your own code, right? And then Monday will come and you'll be like, eh. So we're looking first, we're going to write our test, and immediately our test is going to fail because there's no code to back it up. Right? So that's good. That's what we want. Then we're going to start writing our code to start meeting our test conditions, which really should be the requirements that we've gathered from the customer. And then we're going to continue to refactor our code until we meet and pass that test, so that we have good quality code. We know that that code is meeting our tests. And things are going good in our things. So the number one rule, and this is the biggest problem that George and I see with anybody who's really starting to get into the game of testing. Don't test other people's code. Test your code. You don't need to test the JavaScript API. That team does a great job of writing unit tests and all that. Don't test React code. Don't test your framework code. Don't test, like, all those are being tested by other people. Now, sure, occasionally you might find a bug in them or something like that, but that's their job to test their code. You know, they accept issues. I'm sure they'll tell you they accept pull requests too, but, you know, log an issue. Move on, do your code. And so, but this is a mindset that's really difficult for people to understand, because they're like, well, I'm interacting with the map, or I'm setting something on the view. So we're going to talk about how you're going to do that later. We'll show you in detail what are called spies and fakes and things like that, so that we can get around having to rely on these other people's code to really test our code. Prioritize your tests. Achieving 100% code coverage is unreasonable. In the tagline for this, we said we want cost-effective unit testing that's going to make our code better, help us to deliver faster. Achieving 100% code coverage is not going to let you do that, right? So make sure that you're choosing the right things in your code to test. Sure, the more code coverage, the better, but don't be unreasonable about it. Like, which would you rather have? A code with some tests or code with no tests? We need to choose some tests, right? So whenever we're looking at that and prioritizing and thinking about the different types of tests that we might have, at the very top we have functional tests. So this is something where, like, the whole app is spun up. We're capturing, like, clicks on the map and panning and zooming. And the thing about these tests, it costs a whole lot of money to write and maintain them. It takes a lot of effort to keep up with them and run them. They're difficult. We have a whole complex system going on at that one time. Now, down at the bottom, we have unit tests. This is where developers are living day to day, knowing that the snippet of code that they're writing is then going to do what it's required to do, that it's meeting the requirements of whatever piece they're building into their software. And we definitely have things here in the middle, you know, going from the very small piece of code, a little bit larger in component, integration tests as we put our components together, API tests and functional tests. So you can see time goes down as we go to the big end of the chart, and cost and effort goes up as we go up that pyramid. So we're going to focus down here at the bottom. The time and the cost effective sweet spot in our mind. So George came up with this a couple of years ago, the nightmare test pyramid. So when we have the bugs and we have that massive functional test up there at the top of the pyramid, that's where this gets flipped upside down, because the nightmares grow the bigger and more a test is testing, right? So we want to get down to where the nightmares are small. Even dreams are nightmares. So that single functional task that hasn't passed in years, that's terrible. So what we want to do is, in our other pyramid, we want to get small and down and testing those small bits of code. So to maintain that, though, you have to encapsulate. You have to take your code and you have to put it so that it's really only doing that one thing that it's supposed to do, right? So, and then as we're developing things, if it's easy to test, it's going to be easy for you to maintain. Something breaks, some requirement comes in that, you know, changes what needs to be tested, changes a value. You know, we'll look at some examples later, like maybe we're looking at something with a scale dependency or something like that, and they change, they say, well, no longer we care about 6, we care about level 8, right? So you're going to know where to do that because you can go change your test or test the requirement and you're going to know exactly where it's going to break. And then you're going to go fix your code because the requirement changed, right? So you're going to be able to maintain those small snippets of code much more effectively and much easier. So now we're ready to get into demos. I think George is going to start with us from the new application and then we're going to move through those other scenarios.
All right, there we go. I know how to press buttons. All right, so we're going to start out, we're going to look at how things might look if you were going to start a brand new application and you wanted to do things, you know, picture perfect. I want to really do test-driven development. I know these opportunities are pretty rare. Usually we're working on something that somebody else left us with maybe 5 years ago. Maybe that other person's us from 5 years ago. I know I was a terrible programmer 5 years ago. And 5 years from now, I'll think the same thing. So when we start setting things up, we really don't want to have to go through that process every time, right, of what's the best modern tooling, how do I set up tests. I know I never remember what to do to start a new project, right? I can fix bugs, I can get into the code, but to actually start a new project, it's such a rare occurrence that it's like, okay, I put a widget where? So we have some tools out there for it. This is the ArcGIS JSC CLI. And what this is going to do is it's going to set up all of the basic pieces of your application with modern toolings. It's going to have Webpack. It's going to have test frameworks. It's going to have really everything you need to get going. So let's pull that up in code and take a look here. Now I'm going to attempt to be just developing this from scratch here. So bear with me for any typos and as we work through it. All right, so this is this code right here. Can everyone see it? All right, great. So this is built with the CLI. You can see it set up quite a few things. I've got my source directory here. I've got a test directory with a whole bunch of unit tests that are already made. And I made this by navigating to the directory below where I want to create the app, and then just typing ArcGIS, create, and then my app name. Once you do that, it'll spin up all the basics, it'll install all of your node modules for you, and get you ready to go. That's going to have everything minus this Palm Springs widget here. Now, it takes some time, so I ran it beforehand. I know you guys like to see code on the screen, but you probably don't like to see a loading bar for 20 minutes. From there, we can add new widgets by going to ArcGIS widget, and then the name of our widget. And once you do that, that's going to add a Esri JavaScript API widget to this widgets folder. And it's also going to add the related tests. And this is using all of the JavaScript API team's best practices. So you can see here it's using TypeScript. There are TSX files to handle the view. And then there's a separate TypeScript file in here to show the view model. And what that does is it creates an app that looks like this. All right, it's a pretty simple JavaScript API app. It's got a map, it's got a header. You can see the widgets for that in here. The header's just very simple, has the name of the app, and the app has some setup for us, right? If we look at the tests that it creates, those are also pretty simple. So it's got the app view model, and that's got some things like saying that it's using a feature layer. These are simple, meant to just be there to show that a test can work. In the widget that I created, though, it has much simpler tests, right? It just says, okay, verify that the property name is there. We can go in, we can change that, but if we actually run those tests by typing npm test, we can see that they run. And if I were to change the name, it would fail. From there, we want to start thinking about what our requirements are, what our client asked us, before we really start to get into general coding, right? So we want to have the client in mind when we're actually designing our widgets. So let's say our client came to us and said, I want to create a widget that just validates a coordinate string. So I want to be able to enter that text into the box, click a button, and say, yes, it's valid, no, it's not valid. A pretty simple widget, but something that's doable in a talk, right? So we go through here, and we could start writing tests now, but as a developer, I know that's pretty unrealistic. I want to see my widget on a map. I'm probably not going to test, that the form fields are in the right place, that the button's there. That stuff, UI type things, are really hard to test. They don't necessarily give you a lot of value either. Every time you change a small tweak in the UI, you're going to have to rewrite your tests. It doesn't really affect functionality. It doesn't affect things that are particularly important for your client either. So you don't necessarily want to be wasting your time doing that. Let's go through here. Let's delete this test that we don't need. And let's start looking at building a widget. So I'm going to go to our app.tsx, or the app view model here. And if you're not familiar with the view model type framework, really all of the logic we're going to try to keep in our view model. And we're going to try to keep these TSX files to just have some of the more UI components. So down here you can see we have properties, we have some onload functions, and that's where we're just going to add our widget. With the Esri widget framework, you can go through and just add it pretty cleanly. So I'm going to say const Palm Springs equals new Palm Springs. Or I will import it first. Port Palm Springs from /Palm Springs. Dot. All right, and you can see that works. It's giving me a green underline because I haven't used it yet. And I'm going to go through here now. I'm going to say Palm Springs equals new Palm Springs. This.view.ui.add Palm Springs bottom right. Then we should be able to go back here, wait for that to reload, and get our widget to show up on the bottom of the screen. I'll let that load in the background while we get back to the code here. If you look, I have running in the other screen just a Webpack piece running automatically. So every time I'm making a change, it's refreshing. And that way I don't have to worry about things. And you can see I have my little widget here. But that's not really what we wanted. We wanted a form. So I'm going to go through here. I'm going to actually go down to our Palm Springs widget now. And I'm going to add my UI. So we can keep this div class here, and I'll just say an input type equals text, placeholder of Palm Springs, or coordinates. And then I'm also going to add a button. And that button's just going to say validate. So now we have to hook those up to our actual, to our work here. When you're doing that, you're going to want to have a onChange piece. And I'll just say update coordinates and an onClick to validate. And that's going to be done in the view model. So we go to this .view model .validate coordinates. So now we're kind of getting somewhere where we might have to write a unit test, right? We have a widget on the screen, we have everything set up there, and now we're getting into the logic. So validate coordinates is something that is testable. It seems it's going to be, input for an output. So we want to actually flesh that out. I have some test values that I wrote down here. just so that I don't have to come up with them on the fly. But we can go in and we can put those into our test that's already been created for us. So that's in this, down here in unit tests. And we go to Palm Springs and the Palm Springs view model test. So you can see here, this basic unit test framework, before each test, it's just creating a new view model. But then we want to create a new test. So we say test, and it's going to be validate coordinates. And the great thing about working with TypeScript here is that when we're writing tests, when we're writing our code, we can see what is actually required in that function while I'm typing it. So I don't have to remember frameworks for everything. You know, this is using the intern, which is a specific type of testing framework, but this applies to anything. So if you were to spin something up with a different CLI, or you were going to spin something up on your own with whatever trendy testing framework you happen to read a Medium post about, you would see everything that comes with it. So I can see I have my name, and then I need a test function. So I'm just going to create a quick function here without accidentally deleting all my code. And that's there. And I'll say we want to have some test coordinates. So I'll do copy that there. And now I have this coordinate input. I know it's going to be there. And I can say, you know, coordinate input for each of these. I want to run a new test case. I pull up each test case and I say the view model, and then I'm going to, again, validate coordinates for the test case.test value. And you can see that's just a collection of strings that I've put together here, where we have some different things that people could enter in the field, and whether they're going to be true or false there. I have X values and Y values, but we'll get into those a little bit later, why I put those in there. So once I have that, I can say that's there, and I can say valid result equals that. And then we just need to assert that strict equals. And that's going to see the actual value, which we know is valid result, and the expected value, which is going to be the test case.valid coord. Okay, so now we have a test. There's no way this test is going to pass. There's not even a function that's called validate coordinates. So we can go in here and we can actually make this function validate coordinates. So I'm going to go back up. And this does have a lot of going back and forth, but you'll see how it can kind of force you to break up your application in a more meaningful way, so that when you're breaking things up, other people can come in and understand exactly what's going on. So now we'll delete this name because we're not using it in ours. And we'll go ahead and we'll add this validate coordinates function. And that's going to take in a coordinate string, which is a string. All right, and now we have this function. We can go in and we can say, make sure that we got all our names right here. Validate coordinates, validate coordinates. And then from there, I can start putting what I think would be good code. I can actually start working on it. I'm going to go through and I'm going to say, all right, first things first, I want to break up my string by a comma because this is coordinates. So I'll say const coordinate array equals chord string dot split around a comma. And then I'm going to make sure that I have something to check that they're numbers. So I'll say x equals chord array of 0, and we'll parse that into a number. And then we'll do the same thing for y. All right, so now we can check here. We can say if x is less than 180, or x is greater than negative 180, or y is less than 90, or y is greater than 90, right? And we'll go through and we'll create that. And we can say if that's true, we can return true. And if that's not, we want to return false. So a pretty straightforward function here. Let's run our tests. And while that's running, you can see we did a decent amount of work in here. There's a number of components. If we look through here, that'll load. It's still compiling. But we have this coordinate box here with the button, as we talked about. That wasn't something that we needed to test. It's not something we went back and forth on really aggressively. If you were looking for 100% code completion, right, all that code where we're rendering a button and we're rendering all that, your project manager would be like, okay, we need to pass that. That needs to be tested. But again, there's not a whole lot of value there, because really at that point, you're testing TypeScript and you're testing the JavaScript API. So we put in a number here, and just to see it's doing things. If we look at our tests, we can see where we're at. That's still running. One of the other things you can do that I don't have configured here, but as you're working day to day, you can set up a package similar to what we're doing with the build. So it's watching that and it's testing it every single time. Let that run, and you can see that's probably going to fail. I think you can all see why. We have the numbers wrong here. I've done y is less than 90 and y is greater than 90. And we'll talk about the best way to work on that now. So when that does fail, we're going to see that some of the results were wrong, and we can see why. We can't really see why. And normally, I think most people as developers, our first instinct is to just go into the code, right, and to start putting maybe console.log statements in there, console.debug statements in there, which is great, but at the same time, it doesn't do anything to help the next guy, right? So if you're working on something that becomes more complicated, as you start fixing these things, why did you have to go in there and learn more? How's that going to help the next person to go in there? If something does break, how do we know exactly where it broke? They passed. Okay, so there's something wrong with my test. But like I said, this is a live code demo, so things are bound to happen. We're going to go through here, and this should be negative 90, but we don't know that. So we might want to break this up, and we might want to, say, split up the X and the Y processing. Right? So we could say, what is breaking? What isn't breaking? Maybe there's an issue where the coordinate on 1 is, I know what it is. So the one thing you do have to do that the auto widget doesn't let you do in this one is you have to go into this all suite right here, and you have to add your actual test. So I can do ./widgets /Palm Springs /Palm Springs view model. And that'll actually add that to the test. So we'll let this run in the background while we work on refactoring some things to fix the test. When we go in here, now we can do something like maybe split up the X and Y so that we can see what's being returned is what we expect is being returned. We could check validating them one by one. And as we're doing that, not only are we getting debug statements for ourselves in the form of a unit test, but now we're actually getting useful tests down the road. So it's kind of two birds, one stone here. So let's do get X from string and to get Y from string. And now you can kind of see why I had the other data in my test data. So I can go back here, and I'm going to write tests for these before I start filling in all of that code. So we go back to the Palm Springs value here, and we're going to make another test. Let's move this guy out and into here. That way it's available for all of our tests. I'm going to say test, and we're going to say X generate X, and make that a new test. And then we can go down and do the same thing for y. And now we can loop through that same test data. So I'll say coordinate input dot for each test case. And we roll through here, and we're going to make a new function that's going to test each of those. So here I want to assert that another strict equal, that VM dot get x from string on the test case. I want to make sure that's equal to the test case dot x value. And then I also want to say here, put a little message and say unable to generate valid x field. And I can do the same thing for y. If we were being more efficient here, we might try to make a helper function so that I'm not copying and pasting everywhere. And we'll just change that to y. What's that? Thank you. All right, and so that's kind of what we're going to do there. That'll run tests, but I know what you guys are thinking, and everyone always says it when you start talking about unit testing. It's that, okay, you're validating text, right? That's the obvious unit case answer. That's easy. You know what your inputs are. You know what your outputs are. I have a map. You know, like, how do I test a map? How do I test that I'm panning around? How do I test that things are actually happening? So let's say that same client, after you validated the coordinates, was like, this doesn't meet my requirements. I wanted you to pan to them. And you said you didn't say that, and they said, I don't care. And you move forward with your life and you do the work they tell you to do. So we go through here, and we're going to do the same sort of thing, right? We're going to go and we're going to make a new function. This is going to be the theme over and over again today. So we go through here, and we're going to, our new function will be pan to coordinate. And then we can just say, we can use that same coordinate string maybe, put a string in there. And what we're going to do to really focus on the encapsulation, because I know what most people would do here, myself included, if I'm putting something together really quickly, I would say, okay, I want my, I'll say this dot map view dot go to, and then, you know, x comma y, and that's going to be this dot get x from string, and vice versa, this dot get y from string. And what that's going to do is it's going to give us a strict dependency on this map view and make it a little bit harder to test. Developers are really good at writing code that's hard to test because we know exactly how things should happen right away. But a lot of times you want to be injecting classes in, and that way we can avoid this. We don't want mapView.goTo to be called within our test, because then again, that gets back into, is the Esri class loading correctly? Is it going through and calling all the things on the map? Is it returning the right value? Like Randy said, the JavaScript API team already figured that out. So instead we're going to do something else. We're going to take out this, and we're going to put in here a map view parameter. And we'll say that's a map view. And we can need to import our map view so that we can pick up the types, of course. Import map view from Esri /views/map view. And we can go through there. And now we no longer have to do this. We can just say mapView.goTo. And what that's going to allow us to do is here in the in our view model, our actual view, we can do something else. We can say here we are doing coordinates, validate coordinates, but now we want to pan, right? And we want to pass that map view. So I'm instead going to pass the map view to that function. And I'll do this. I'll say pan map. And again, I'm not writing tests for any of this. This is my boilerplate. I'm pretty confident it works. It doesn't change once we get it in place. So it's not really a high value test. I don't need to write tests for it. I can go through here. I can say pan map, and that's going to be a function that takes a coordinate string, or rather we'll grab the coordinate string from our input, and I'll say this view model dot pan to coordinate, and I can pass in this dot map view, which we can add in the application, and I'll say coordinate string. And what that allows me to do now is I can completely mock my map view. This is a really important concept in unit testing. Mocking, spies, fakes, it's how you get around other people's code. It's how you actually get around your own code. Because I may have a function that calls a number of my other functions, but I don't really want to test those. I know how they work, or how they should work, and they have their own unit tests. So now I'm going to go back to my test here. And I'm going to install another framework. And this is a mocking framework. There's a few different kinds. I like this one called TSmaketo. And what that does is it allows you to do type enforced mocking. So it works really well with TypeScript. I'm going to go ahead, and that's just an npm install save dev TSmaketo, and then I can use it in my tests however I want to. I'll pull up a test that I have already written with this, and we can take a look at how that works. All right, so this is the same app, but with testing done from a hotel room instead, so it's a little more clean. And we can see here that I'm in a same coord input, but this time I'm looking at panning to the point, right? So I'm going to create a mock here. And that mock is of type map view. And there's some boilerplate that you need to instantiate for this particular framework to have it working. It's going to be just a view equals an instance, and then I'm going to pass in what that instance is returning. And that means I'm not actually going to call the map view at all. I'm just going to call this fake thing that returns the correct value, but nothing really happens. So it goes through, I pass my test value there, and all I'm doing right now is I'm verifying that goTo was called. I could do something else if I really wanted to make sure a specific coordinate set was getting called. I could pass that in here. But right now I'm just using this keyword anything. And what that does is that means I don't really care what I'm calling on. I just want to see that goTo was called. That's really useful, again, for getting that efficient and resilient test. Because we talked a lot about prioritizing based on value. But where you really fall down on value is when you have a test that breaks every time you change any little thing. So we're already testing that the coordinates are valid. Why do we need to test that the right coordinates are going into that? It's just getting past a function. So we're going to say go to anything, and that'll be called there, and it'll validate. So that's kind of how you would get started. This is a really simple feature. As you grow, you want to make sure that you're breaking down all of your features into the smallest chunks possible like this. And you want to make sure that as any bugs come up, right? So I have these coordinate inputs that all of my tests are running on. And maybe somebody puts something new in. Maybe they put an emoji in and I wasn't counting on that, right? And it breaks my whole application because this is doing more than validating now. What I can do is I can just really easily, before I start, now I don't have to write a new test for that bug. I don't have to worry about it. If I want to test that case, I can go here and just put in a new test value. And then every place where I'm testing on those values is going to test that. So I could say, test value equals, this is something we didn't expect. And And that's going to roll through, and that's going to give us what we need. So you can see where that would be useful, especially if you're doing network calls, if you're relying on API calls, or something that you're getting back from the JavaScript API, right? So if you're getting information back from a query, now instead of working on that information as soon as you get it back, you can do something like just pass it to a function that's doing your next piece, and you can have an array of different query results that you've found to cause problems in the past. And as those run through, they validate that you're not going to have any regressions, and that bug that comes up once every other quarter, you'll know as soon as you break it again. So that's kind of a brief overview. I know some of the tests, we're just kind of running through them. Randy's going to go into a little more detail now on what to do if you don't have all this amazing tooling from the beginning. If you've got an app that's been going on for 5, 10 years, it's had, 16 developers work on it, and you don't really know what's going on. Maybe it's a mix of different toolings that have been trendy every month for the last 5 years. That's a more realistic case, and he'll take it from there.
So we're going to talk about this amazing legacy application that George and I have been built and using for a number of years here. This one in particular looks like it needs an extra new coat of paint, but otherwise, it's perfectly serviceable. So this is the URL, and we'll have it again at the end. So this is the URL of the project in GitHub. And we actually showed it yesterday as a way of taking a legacy application and adding a Webpack build to it versus the old Dojo style build that we were doing for production. So if you're interested in that, this is a great project for that as well. Here's a project page real quick. So George was showing writing tests with Intern. And so that is a great way to have sort of the test runner and the test framework all packaged together. Intern's come a long way over the last couple of years. It definitely used to have a higher bar of entry than it does today. So you can certainly use Intern into an existing application. This application is currently using Karma. Karma is a great test runner. And it's just what we chose back in the day. It was the hot new thing, like George was saying earlier. It was the hot new thing, like back then. We're using Jasmine to write our test cases. And so what does that sort of look like? As far as what does it mean to bring this stuff into your project, we're bringing in Karma. We're bringing in Jasmine Core. You can see this is my packaged JSON for the project. These are most of the main parts of the test that we've added to our project that will help us with all the testing. And Karma has a config, sort of like George was showing with his other one. One of the nice things about what we have here is when we include all of our tests, we have it with a regular, you can't see that way. We have that with a regular expression. So as we add new ones, it just picks them up and just keeps going. So that makes this one easy. This is what the app looks like. Super simple. Sort of like what George was showing before. It's really simple. We just have it hiding and showing a couple layers. So what we want to sort of talk about here is we've had somebody come in and give us a bug. They're saying this hide asset button is supposed to hide at a certain zoom level, and the tester doesn't think it's the right one based on the requirements. And so they've asked us to go back and look at that bug. So let's look what the project looks like, see if we can add that as well. So this application is really simple. This is what we're calling the toolbar over here. So we have our toolbar class. You can see it's not very complicated. It's just really a few hundred lines of code to do all the functionality that it has in there. This is sort of the section that we're looking at to start with. Whenever the widget's created, we look to see what the map view zoom is, and we figure out whether it's enabled or disabled. And this is great. And this is a great example of a place in our code that we need to refactor. So I'm not really sure why the zoom level's not right. I can see that it's 6 here. I don't really know what the requirement was though. So I'm gonna go check out what the test looks like. Now in the Karma world, they put all the tests in this spec folder. And so now we're looking at our toolbar spec. I do sort of like some of the nomenclature that Karma does versus intern. And because I'm running a test of describing my toolbar components, and we have this before each concept like intern did, and then I'm testing it clears graphics in info window or toggles the street map. And so I come down here and I'm like, oh, sweet, there's a test for enables assets button. And I sort of started a little work while George was talking over there. And I can see, oh, nobody really did anything. So this was a great example of best intentions didn't happen. So I can see though that my zoom level is apparently supposed to be less than or equal to 10. But there's no way, you know, somebody went in here and with the best of intentions probably changed this value at some point and didn't even realize that, you know, it was a requirement that it was supposed to be like this. And so what we're going to do is we're going to do a couple things here. First, there's no way for us to test this code right now. None at all. Like George showed how we test a function. We test what that function does, and we can't do that with this one right now. So what we'll do is we'll convert this into a function of its own. So we have the set assets button state function, and let's get rid of this hitch here. So now I have a function. It has a parameter. You can see the code isn't that bad. Like it's got sort of all the things that we needed. It was, you know, it wasn't even copied and pasted like George mentioned before, you know, so they did some good parts of this thing. But so what we're going to do is we're just going to hitch this together because we're both setting the initial state of it and we're going to watch in case it zooms. So now we have a testable function. We can come back in our toolbar spec. And we're going to call set asset. I think I got that name right. Awesome, just to make sure. And you know, we'll give it some values here. We'll give it 10 because that's what it's saying here. And you know, I could easily sit here and create an array sort of like George did with like all my zoom levels to really make sure that you know, I'm getting the correct one. And so what I want to do is I want to test this after it's been called this case. So it should be disabled. So disable should be truthy. And over here for this next one, calling with the level disabled should be falsy. So in this particular project, I'm going to get this running here. So I'm just doing a npm run start. If you're not familiar with that, that's just an npm script that's been set in my package JSON. So we looked earlier at that package JSON down here with sort of our testing components. And we set, whoa, that's not good. We'll have to figure that out in a second. So we're running this start command is what I ran, and it's going to run in parallel this serve dev, which you can see is my Webpack running in development mode. And then it's running my grunt tests, and it's setting up the watch.
You've got a equal sign on your function instead of a colon.
There we go. Thank you, George.
Sure thing.
Try to. There we go. So if we look over here in the Unit test failed. Oh, here we go. So our unit test failed, as we expected. So this is what we're getting. Expected it to be false when it was truthy on the toolbar enables asset state. So I can come back here and I can see what my test is doing, verify what it's testing for. Okay, so zoom level is less than 10. I can come back over here. I was like, oh, well, this isn't right at all. So I can set that to the correct value, and we can run this again. And so now this time, we can see that the first couple tabs that were open, the app never finished, and that didn't sound good, did it?
Yeah, I mean, usually when you're putting together these tests, it's like any other sort of development. It takes a lot of back and forth, obviously. Small syntax errors can break things. Again, that's why we have things like TypeScript and some of those new toolings to help you out a little bit more. While Randy's looking at that, or maybe fixing that, I'm going to just go over a few other cases here that you might run into while we have time. So a lot of people are talking about, are using React, they're using Angular, they're using really anything, any framework. Maybe next week there will be a new trendy one we'll all be using. But there's this really great app here called Nearby JavaScript that Renee wrote. It's a sample of using the JavaScript API with React, and it has a ton of great unit tests with it as well. So if you go into tests here, you can see this is also using the intern. And he's got unit tests, so if you're looking like, how do I even set up a React app with JavaScript? That can help you here. But if you have a React app and you're like, how do I even test that? This is another good place to go. You can look at how he did it, how he's getting around using the JavaScript API. So if we look in his map test here, we can see that he's using stub from Synon, which is another kind of mocking spy library. And that's going to be super important. You'll use those over and over again when you're using something API heavy, like a mapping application. And you can see if we look at this add locations here, he's making all sorts of stubs, setting them up to return the values that he wants to test for. And then he cleans it up in the after function. So you can see he's looking that we're adding results to the map. So he calls this add locations function that he has defined. And then he just expects that these things are called because he knows the JavaScript API is going to take care of that for him when he calls them. You can then look again to really make sure that your input to those functions is what you expect. But that's the first step. Another piece we want to talk about is the web app builder. How many people here use the web app builder? Okay, a lot of people. So again, these concepts carry over, right? They carry over beyond JavaScript. If you're looking at C#, Java, any sort of backend language too, the tests are going to be the same. You're going to be mocking things. You're going to be injecting types, things like that. But in Web App Builder, it can be kind of tough because of all those internal libraries that make Web App Builder what it is, and because of the tightly integrated Dojo requirements, right? So what we do for Web App Builder is we don't write Web App Builder widgets when we're working on Web App Builder. We wrap JavaScript API widgets. So if I look at this, I have a widget, and that has my standard widget JS, widget HTML that you would expect. And I can click on that, but it doesn't really do anything. It creates a new widget, right? And this is just a plain JavaScript API widget. And that has a number of really good benefits. So number one, it doesn't require any Web App Builder classes, so I don't have to worry about that. And number two, it's just a JavaScript API widget. If I get new requirements, if I don't want to use Web App Builder anymore, if my customer suddenly decides they want something small, lean, and mobile, I can move to the JavaScript API and just drop my widget into there now. I have a fully portable, testable application. This one, again, is very simple, but demonstrates that concept. So if we go back to our test example main folder, we can see this spec directory, and I have a very simple test here that's making a fake view. This one's not even using a library to fake it. I'm just making a new JavaScript object that does nothing. and then I check to make sure that it got called. And here I'm even checking to make sure that it got called at the right coordinates. So you can see how really the key for not just Web App Builder, but something very framework heavy is, again, encapsulating your code away from the API's code, taking the thing you want to test and making it very discrete and standalone. All right, so that's a broad overview of everything we've done. I think, Randy, did you get your test working?
Yep, my test works now.
Excellent.
So you can see here, this is sort of the output of Karma in our case. So we see that we have 4 out of 4 successful tests. One of the nice things that is set up in this particular project is it watches those JavaScript files so that as we make a change, so that we're actually testing less than 10, rookie mistake on my part. You can see that it automatically is both linting and rerunning my current tests as soon as I save the JavaScript file. It's already going, and I can now know, see that, and this would happen if I were to change both either my class or my test. It reruns it all as soon as I save it. So that's great with that. So a few other things. George is giving a talk with Gavin here later this afternoon in the same room to go deeper on the Web App Builder side. Yeah. In both of our talks, we sort of mentioned the Yeoman generator that's going to help you scaffold out Web App Builder widgets, and so you can start applying that encapsulation model that George talked about. They're going to deep dive on that. We have a couple slides here related to both the resources that we're using, and then after everybody has a chance to take a picture of that wants to, we'll go over into the tooling side of things. So like we started this talk with, we really appreciate your feedback. We don't have a lot of time today for questions, but George and I will hang around afterwards if you guys want to come up and you have any questions for us. Looks like one more phone. There we go. Here's the tooling slide. So both the CLI example and the React example that George showed was using the intern. The example that I showed with the existing app was using Karma, and Jasmine was the language that was used in that one. And then sign-on and Maketo, the TSmaketo specifically, were the ones that George used additionally with intern within the new project. And was Maketo in the nearby project too?
No, I don't believe so.
Okay. Yep. So so here's tooling for you. Somehow we lost our. Oh no, there it is. It just got further than I thought it was. We do care about those surveys. We really do, and so we appreciate if you give us that feedback. We'll incorporate it for next year. And 2 minutes. Do we have 1 or 2 questions? Maybe we can take while we're still in our time block. Anybody have any? Yes.
Have you guys investigated property-based testing?
The question is, have we investigated property-based testing? I haven't, or I guess, well, I don't know.
I'm not sure on that particular framework or methodology, so
yeah,
I'll look it up.
Are you talking about like property-based, like on the property of a particular object?
No, the kind where it effectively generates all the possible inputs for it effectively breaks through the test case.
Oh, right, gotcha. Okay. Yeah, we haven't really looked into that too much. I've seen it been done, like I've seen it done too where it's randomly generating a number of inputs for like string inputs and things like that. We haven't really worked on anything where we have too much of a need for that, but I think that would be really useful. And if you were working on a public-facing application where you really have no idea what the user's going to enter, or you really have to account for all things, that's something where you can really just add it on to the same kind of concepts we're doing, right? So the main concepts we're trying to stress here are that encapsulation and the mocking of functions. So no matter how you generate your tests, no matter how you're building things out and getting the coverage you want, that's what you really want to take home from this talk.
Yep. Any other questions in the 30 seconds we have? Yes.
Intern seems to be quite slow. I agree in some ways with fast tests, so you can run them as you're coding. Is there, other libraries much quicker or?
So the question was that in our demos up there, intern seemed pretty slow. Are there other libraries that are quicker? I don't think it was necessarily intern that was causing that delay, but Webpack probably. So in the way that app was being developed, we were running Webpack each time before building out the application. If you were using a different build method or not building at all during your development, that would be much quicker.
Yeah.
So, and yeah, in your development, that's probably a good way to save time. A lot of times we'll just have it automatically rebuilding so that it can kind of be on in the background and you get a ding or something when it fails. So that's another way to make it easily integrated into your development.
Yeah.
Cool.
Well, I think we're at time, so if you have any other questions, feel free to come up, and we will also be at the JavaScript Island if you don't catch us after this talk. Thanks, everyone.